After years and many DX radio connections, the antenna smoked. We examine what the problem was and what the solution looks like. Today I have something spectacular to report. It's about a relatively expensive amateur radio antenna that a friend of mine has been using for a number of years. He is an ambitious amateur radio operator who, by the way, is a real expert in high-frequency technology. One day his antenna's VSWR deteriorated rapidly for no apparent reason. A closer examination revealed a rather strange behavior. A barely acceptable VSWR could be achieved at a very low transmission power, but at high transmission power the VSWR suddenly became very bad and even fluctuated. Other ham radio operators reported that they receive poor signal levels from the station, which was no surprise given the poor VSWR. What can you do in such a case? First of all, it's always good if you can rule out simple malfunctions. So he checked the antenna cable with an ohm meter to rule out a simple broken cable or a loose connection. The result was that the antenna cable was obviously fine. And then he measured the return loss and the VSWR of the antenna with a nano VNA. The reflection measurement showed that the usual very good antenna matching was no longer possible. So the antenna itself must have been damaged somehow. We're talking about a tunable and rotatable 3-element Yagi antenna with an extendable mast. The antenna construction consists mainly of GRP tubes. Conductive bands are located in these tubes, the length of which can be adjusted using stepper motors. As a result, the antenna can cover several frequency bands and the impedance can be matched very precisely. Actually, a really great antenna. Now let's take a closer look at the antenna. I have to mention that it's really no fun to climb on a house roof in Germany during the winter. A small detail is already noticeable on our antenna. A piece of the GRP tube has a slight kink. The kink and its dark color look pretty suspicious. So the antenna had to be dismantled and disassembled. And that's what came out of it. The conductive band of the dipole, which is the actual antenna, is quite heavily oxidized along its entire length and even partly burned off at the front end. The parts of the aforementioned kink look pretty spectacularly destroyed. What happened here? Obviously, there must have been strong sparking, which then burned parts of the GRP pipe. As a result, the pipe was slightly kinked. But how can spark discharges occur at this point of the antenna? In order to clarify this, we now make an estimate of the voltages that can occur at the fed dipole. We assume that the antenna is fed with 100 watts of transmission power. Together with the characteristic impedance of 50 ohms, the effective voltage and the peak voltage U max equals 100 volts can be calculated from this. U max is the voltage we have at the dipole feed point. A radio operator knows that when a dipole resonates, you get voltage maxima at its ends. But how large is the electrical voltage getting there? We remember, if you want to feed a dipole antenna at one end, then you need a balloon that transforms at a ratio of about 1 to 50. Because the impedance of the antenna at the end is in the kilo ohm range. Since voltage and impedance are proportional, the voltage at the end of the dipole is higher by a factor of 50. That's 5000 volts at the dipole ends. In case of higher transmission power, the voltage could go up to 25,000 volts. Sparks jump about 1 mm per 1000 volts. That means, in our case, a spark could easily jump 5 mm in air. Okay, but the physical distances for the antenna are all much larger, aren't they? Now let's have a look at the burnt parts again. The parts were installed at this point of the antenna. Here the GRP pipe is held from above by a rope, and we have an aluminum bar between the GRP tubes, which makes the whole construction more stable. Let's speculate a bit where the weak parts are and how sparks could find their way. Here are two plastic construction elements that held the whole thing together with screws. Then we have the GRP tube and the inner PVS tube where the band conductor runs inside. So far I see no problem. But now we have the set aluminum bar here that obviously comes very close to the tubes. It is insulated from the antenna conductor by the GRP tube. However, it is only a few millimeters away from the metal band on which the high voltages occur. Our resume is now the following. The GRP material has aged over the years and has got hairline cracks. And then some moisture got into the cracks and the spark breakthrough to the aluminum bar was unavoidable. Next, a vicious cycle began. The sparks burned more and more holes in the GRP pipe, more and more water penetrated through them, and there were more and more sparks. This also explains the strange behavior of the VSWR. The aluminum bar does not affect the radiation properties of the antenna, but given the high voltages in that area, it wasn't a good idea to use conductive material here. The repair was really expensive and time-consuming. The conductive tape had to be replaced along with the winding mechanism with the stepper motor. Of course, the complete dipole part of the antenna had to be taken down from the roof and dismantled, repaired and then mounted to the mast again. Here we see a test that was carried out during construction. The conductive metal strips extend and retract when you want to tune the antenna to a specific frequency. With the new parts, lots of time and effort, we managed to get the antenna working again. Incidentally, the aluminum bar has now been replaced by a GRP bar. We believe that this will prevent the problem from occurring again, even if the GRP tube of the dipole leaks. At this point, we would like to thank the helpers, without whom the repair would not have been possible. But the antenna is very interesting. As I said, my friend has already established many long-distance connections with it. That's why we decided to analyze the antenna with NEC in order to better understand its properties. We are particularly interested in the influence of the environment on the radiation characteristics of the antenna. So, if you are interested in the topic, stay tuned and subscribe to the channel. The insights. In this case, the problem could really have been avoided very easily by constructing the bar from non-conductive material from the start. GRP material ages due to the effects of solar radiation and frost. After a few years, it just doesn't insulate as well as it did on day one. Incidentally, my friend was lucky because his transmitter amplifier was not damaged by the malfunction of the antenna. And now I'm looking forward to the coming episode about the neck analysis. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.